Today we're going to be starting a new unit on finance, and today we are going to be talking about simple and compound interest. So let's start off by talking about simple interest. What is simple interest? So simple interest is interest that is only on the amount and not on past interest. Typically, simple interest is going to be on interest on loans of a year or less. So how do you calculate what the interest is? With simple interest, you simply need to know P, R, and T, and you're going to multiply them together. Now, P represents the principal amount, so the amount that is being loaned. R is the annual interest rate, and then T is the time in years. Now, the one thing to note for simple interest is because oftentimes this refers to interest on loans of a year or less, the time, since it has to be in years, may have to be a fraction or a decimal of some sort. So for example, if the interest is for 6 months, then you want to make sure that you're putting 6 over 12 because it's only for half of a year. Take a look at example 1. To buy furniture for a new apartment, Candace Cooney borrows $5,000 at 8% simple interest for 11 months. How much interest will she pay? So the amount that's borrowed, that's P, that's $5,000 in this case. The interest rate is 8%, and the amount of time is 11 months. Again, remember that you want to put this in years, so this would be 11 over 12. Multiplying that together, we get this is 366.67. So that's the amount of interest that Candace owes. Now that's not the total amount that she has to repay, but that's the total amount that she has to pay on top of the $5,000 that she borrowed. So really, she's going to have to pay $5,000 plus the 366.67. Okay, well, what if I just want to know how much she has to pay altogether and not just how much in interest? Well, we have this formula. We call what you're trying to find here, what we've described here, as the future or the maturity value for simple interest. So that's the value of a loan or an asset at a time in the future. So here is the formula. You'll notice the P and the R and the T are still there, except now you also have a 1 in there. Really what you have here is, let's say you multiplied this out, you'd end up with P plus PRT. Really what you're doing is you're saying, okay, this is going to be P, the amount that's loaned, plus the amount of interest, PRT. So again, P represents the principal, R the annual interest rate, and T the time in years. Take a look at example 2. Find the maturity value for each loan at simple interest. A loan of $2,500 to be repaid in 8 months with interest of 4.3%. So again, we're trying to find the maturity value, so in other words, how much is owed at the end of 8 months in total, including the amount that was borrowed that needs to be paid back and the amount of interest that needs to be paid. So P is equal to 2,500. The rate is 4.3%, so that's 0.043. And then the amount of time, don't forget to change that into years, so this is 8 months, which is 8/12 of a year. All right, so simplifying some things here and then multiplying things together, we end up with 2,571.67. So the total amount that is owed after 8 months with this interest rate is $2,571.67. All right, part B. Find the maturity value for each loan at simple interest, a loan of $11,280 for 85 days at 7% interest. Assume 360 days in a year. Now for our practical purposes here, 360 days in a year, that's actually fairly typical of many financial institutions in terms of doing calculations. What it does is it's really assuming 30 days per month, and that makes calculations much easier. So a loan of $11,280, that's going to be the principal amount. 7% is our interest rate, And then the amount of time is 85 days. And again, we're assuming 360 days in a year. So that's 85 over 360. And so simplifying this, we end up with 11,466.43. So the maturity value after 85 days at 7% interest is going to be $11,466.43. Now that we've talked about simple interest, let's talk about compound interest. So compound interest is interest that is charged on interest as well as on the principal. So typically, this is talking about interest for longer periods of time. Now, what does this actually mean, and how is it different from simple interest? Simple interest is interest that's only charged on the amount that's borrowed. So for example, you borrowed $5,000, I'm going to charge you interest on that $5,000. Compound interest, as the name suggests, is charging you for interest not only on the principal, but also the interest that hasn't been paid back yet. Here's the formula. A equals P times 1 plus I in parentheses to the nth power. Now, what is I and what is n? So I is going to be R over M, and n is going to equal M times T. Now we're going to go over what everything represents here, and then we'll talk about I and n. So A is the future value, so the maturity value or future value of the loan or the investment in whichever case. P, that's the principal, so that's the amount of the loan or the initial amount that is invested. R is the annual interest rate. Now, M is the number of compounding periods per year. Now, this will depend on the problem. If it says that something is compounded quarterly, then that means there are 4 compounding periods per year. T is the number of years. So then, since we have M and we have T now, if you multiply the number of compounding periods per year times the number of years, then N is really just the number of compounding periods, right? That's the total number of times that this interest has been compounded. I, now that we have R and we have M, we know R is the annual interest rate and M is the number of compounding periods per year. So really you're just dividing that interest rate by the number of times it's compounded per year. So this is the interest rate per period. All right, example 3. Suppose $1,000 is deposited for 6 years in an account paying 4.25% per year, compounded 4 times a year. Find the amount of interest earned. Now on the side over here, I'm going to find I and N before I plug it into the formula. So R is 4.25%, so as a decimal that's 0.0425, divided by M. Remember, M is the number of times it's compounded per year. So this says that this is compounded 4 times every year. Now N is the total number of compounding periods, so we're going to have to multiply the number of times it's compounded in a year times the number of years. So that's 4 times 6. Now I'm going to plug those into the formula. So A is equal to P, which is 1,000, times 1 plus 0.0425 over 4, and we raise that to the 4 times 6. Simplifying that, we get 1,288.73. However, in this problem, you're asked not what the maturity value is, but it says find the amount of interest earned. So the amount of interest that's earned is this number that we just found minus the initial amount that we had invested, which is $1,000. So that minus 1,000 gives us 288.73. So in total, the amount of interest earned is $288.73. Next, we're going to talk about effective rate. So the effective rate is the actual rate that is earned or paid on an investment over 1 year. So here's the formula, and let's talk about each part in the formula. So R with the subscript capital E represents the effective rate, R represents the interest rate, and M represents the number of compounding periods per year. So if compounded quarterly, that number would be 4. Here's example 4. Find the effective rate corresponding to a stated rate of 6% compounded quarterly. So we're simply going to plug this into the formula. The stated rate is 6%, so as a decimal that's 0.06. It's compounded quarterly, which means that there are 4 compounding periods in 1 year, and we raise that to the 4th power. Simplifying that, we end up with 0.06136, so that as a percentage is 6.136%. So the effective rate that corresponds to this is 6.136%. Next, we're going to talk about present value. Present value is the current value of a future sum of money given compounding at a given interest rate. So this would be something you would use if you want to find out, well, how much do I have to invest in order to attain a certain amount given the interest rate and given the amount of time that you invest this. So here's the formula. P equals A times 1 plus I to the negative n. I, as we've seen in a lot of the other examples, I is the interest rate per period, n is the number of compounding periods, and then, as you know, P is the present value, and A is that future amount, or the future maturity value. So example 5, if money can be deposited at 6% compounded semi-annually over 9 years, find the present value of $16,000. So start with the formula, and let's fill in what we know. So we're trying to find the present value of $16,000. That means I want to know how much I need to invest in order to attain $16,000 after 9 years if the money is deposited at 6% compounded semi-annually. So A is equal to 16,000. The interest rate, remember that the interest rate is going to be the rate given divided by the number of compounding periods per year. In this case, the rate is 6%, but it says that it's compounded semi-annually, so you're going to have to divide that by 2. Then, N, remember, represents the number of times it's compounded altogether. You know it's compounded semi-annually, which means it's twice per year, and this is over 9 years, so N is equal to 18. Once you have that all filled out, we simplify this and we get $9,398.31. So in order to reach $16,000 with this rate, with this compounding over 9 years, you're going to have to invest $9,398.31. Next, we have continuous compounding. So continuous compounding is when we are compounding interest constantly or infinitely. In this, you have probably seen this in Algebra 2. You're using the formula P times E to the RT. R is the interest rate, and T is the time in years. Example 6, we have $2,450 deposited at 5.25% compounded continuously. Find the compound amount and the interest earned after 6.5 years. So we're starting off with $2,450, and our rate is 5.25%, so that's 0.0525. And T, the time in years, we're told is 6.5. Now simplifying that, we get $3,446.43, and that gives us the compound amount, but note that this problem is also asking you for the interest that's earned. So to find the interest earned, we simply have to subtract off the amount that we originally deposited, which is $2,450. So subtract that, and we end up with $996.43.